Okay, last question before the multiple choice. So this looks like it's going to be a collision, which means momentum. So here we go. Two railway trucks. They're involved in an inelastic collision. They join when they collide, and then they move together. The trucks move a distance of 15 meters before coming to rest. Well, looks like we're going to have to tie in SUVAT and everything to this as well. Truck A has a total mass of 16,000 kilograms. Truck B has a total mass of 12,000 kilograms. Okay, so truck A. Okay, and that is 2.8. And this is 12,000 and 3.1. Well, this is simply kinetic energy is not conserved in an inelastic collision. Some energy goes towards deforming the two objects that collide. There's thermal energy involved in that, and then there is just the energy to permanently deform something. So in an inelastic collision, there will be permanent deformation. Show that the speed of the joint trucks immediately after the collision is about 0.03 meters per second. So what we have to look at is the total momentum before is always conserved. So momentum before is equal to the momentum after. So momentum before is 16,000 times 2.8 meters per second plus, I know some of you are already screaming it's not plus, but it is plus. It's just you've got a negative velocity in there. Negative 3.1. So I'm looking at this as I'm adding every momentum that I have together, and it's just that this particular momentum happens to be negative because it has a negative velocity. Standard rule of thumb, up and to the right is positive, down and to the left is negative. And that is going to be equal to the momentum afterwards, and the momentum afterwards is going to be our final mass, which is 16,000 plus 12,000 times v, our final speed. So 16,000 times 2.1, 2.8 plus 12,000 times negative 3.1. Okay, so 7,600 is equal to 28,000 V. So V is equal to 0.27 meters per second. Which is approximately equal to 0.3 meters per second. Man, this one has a lot of show that questions on it. Okay, so now we need to calculate the impulse that acts on each truck during the collision. Give an appropriate unit for your answer. So, impulse is the change in momentum. Okay. So, because the mass doesn't change for the truck, it is just m delta v. So 1,000, or sorry, 16,000 was 2.8. Minus 0.27 technically this should be a negative value because this one is slowing down. So actually I am going to do that. 0.27 minus 2.8. So negative 4.0 times 10 to the 4. But because it's for both of them, and it's just, they're both going to change momentum by the same amount. And because it is still momentum, kilogram, meters per second. So kilogram meters per second. So they would... So they would have rebounded. Car A and B, if it was perfectly elastic, so B would move faster than A would have. So basically, if it's perfectly elastic, they just switch momentums. So A will be moving quite a bit slower than, or will be moving slower than either of the two before, but B would definitely be moving faster than A was. B will definitely be moving faster than A was at any point. So that is... Oh, and it's because it has... and this is, I mean, slower than B was moving prior to the collision, and B would be moving faster than A was moving prior to the collision. Okay, so that is that.